Hi everyone. In this video I'm going to talk to you about some properties of quadrilaterals, and I'm going to show you some examples where you can apply these principles in different situations. Let's go ahead and begin with the first example that you see over here. The first thing to note is that quadrilaterals are basically two triangles that are put together. Now, if we go back to what we know about triangles, if you were to take the sum of three angles within a triangle, that makes 180 degrees. And if you were to take any quadrilateral, you could divide it easily into two triangles by creating a diagonal like I just did right there. And that means that in the top triangle, you have 180 degrees, and in the bottom one, you also have 180 degrees. And what that means is that altogether, you have 360 degrees. So the value of all the angles within a quadrilateral, and there are four of them, 1, 2, 3, 4, the sum of them is always going to be 360 degrees within that quadrilateral. So with that in mind, we can go ahead and approach this question. So in this question, what we have to do is figure out the value of that missing angle. To do this, I will take what I know, which are these three angles, and I will create an equation out of them. And it would look something like this. So you would take 110 degrees and you would add 78 to that. Sorry, that looks like 780. 78 degrees. Then you would add 77 degrees to that. And then finally you would include that question mark, so plus the value of the question mark. All that together is going to give you 360 degrees. Now at this point, all you have to do is a sum of everything. So 110 plus 78 plus 77 would equal 265. So 265 plus that question mark, all that together makes 360. And if you simply deduct 265 from 360, what you would get is you would get 95 degrees. And the value of that question mark is 95 degrees. Okay, and with that, that is the end of this question. What is the value of that angle? 95 degrees. Okay, let's move on to the next one. In the next one, we have the same scenario, but what separates this from the first question is that we have larger expressions to work with. We don't only have numerical values, we actually have expressions involving variables. But the idea is still the same. So all of these angles together make 360 degrees. And so with that in mind, I can build my equation. And it would look something like this. It would be 16x minus 6, and then plus 10x plus 4, then plus 82 and 98. All that together makes 360 degrees. Now, once you write the equation, all you have to do is combine terms and continue to break this down until you have an answer. This is 26x, and that's going to be negative 6 plus 4 is negative 2. It's going to make the 82 into an 80, which when you add to 98 is 178. And that's still equal to 360. So you deduct 360 and 178. And what you would get is 182. So 26x is equal to 182. When that's divided by 26, you get a value of 7. So x is equal to 7, but it doesn't answer the question, because what we have to figure out is the actual value of angle t. So what we do is we take 7, drag it, drop it right where you see that x here, and then you do the math. So the measurement of angle t is actually equal to 16 times 7 minus 6. 16 multiplied by 7 is 112. Minus 6 is 106 degrees, which does make sense when you look at the picture, the diagram. You can see that this angle right there does indeed appear to be an obtuse one. So 106 does make sense. Okay, let's move on to the next one. In this next one, what we have to do is find the measurement of, in this quadrilateral. The name of this quadrilateral is a parallelogram, and as you might have guessed by now, a parallelogram is simply a quadrilateral that has opposite sides that are parallel. Sorry, I'm trying to activate my pen feature here. There we go. So a parallelogram is a quadrilateral where opposite sides are simply parallel to each other. So you can tell by the marks I made. And I'm going to color code this as well if that makes it easier for you. So those two green ones are parallel, and these two blue ones are parallel. Okay? So with that in mind, there are some properties that are good to note. Number one is that in parallelograms, opposite angles are always congruent. And visually, you might be able to see this as well. Opposite angles are congruent. So angle G is congruent to angle E, and then angle H is congruent to angle F. So if we have to figure out what the value of angle F is, which is that one right there, what we have to understand is that angle H is exactly the same thing. So we have two of a kind. And because we don't know the value of it, we give it a variable. So I will call it the traditional x degrees. And because the other one is just like it, we can call that one x degrees as well. We can also say that this over here, angle G, is 50 degrees because it's congruent to angle E. And now I have a setup where all four angles are labeled with something, either a number, like 50, or a variable, x. And I can build my equation based on this. And I'm going to say that the two x's combined, or 2x, plus the two 50s combined, together total 360 degrees. And then I just break this down. So it's 2x plus 100 equals 360. When you deduct 100 from 360, you get 260. And that means that x must be 130 degrees. Now, one thing to note about this is take a good look at this angle here. I'm going to highlight it in a different color. This angle right there, whoa, it's a little thicker than I wanted it to be. Sorry about that. That angle right there and this angle right there are each obtuse. And visually you can see that. And mathematically, you can see it as well with that measurement. Okay, let's move on to the next example. Number 9, solve for x. Once again, one thing to note here is the type of parallelogram this is. It is, as it does indicate, a parallelogram. And so what this means, as I said before, is that you have opposite sides that are parallel to each other. Okay, so in this particular example, what makes this different from the one we just did is that we are now looking at these kind of angles. Now, I want you to remember something about parallel lines. So let's take a step away from this for a moment. In parallel lines and a transversal, when you have same side interior angles like those two, A and B, that means that the sum of those angles is 180 degrees. And that makes them both supplementary angles. So same side interior angles are always supplementary. Well, if you remember that, then that is exactly what these two angles here, this one and that one, that's what they are. They are simply same side interior angles. These parallel lines were simply abbreviated or cut off so that you could have this parallelogram figure. But we're still dealing with the same principle of parallel lines and transversals and the angles that are formed by them. And so we have actually our parallel lines and our same side interior angles. So because of that, I could say that this angle F plus this angle E is equal to 180. They are supplementary. And so then I substitute what I know about each angle. So 6x plus 17 plus 97 is equal to 180. And then I just do the math. So 6x plus 114 is equal to 180, which means that 6x is now equal to 66, and therefore x is equal to 11. Now that's not degrees, because as you can see, x is just a tool used to get the value of that angle. So we now have to take this 11, drag it, drag it, drag it, and drop it in right there. So the math behind this would be 6 times 11 plus 17, 66 plus 17, and then the value of angle F would be, so that would be 83 degrees, okay? Now, it did ask only for the value of x, but I wanted to show you that if you know the value of x, you can actually figure out what the value of the angle is through simple substitution. All right, let's move on to the next one. In this example here, we are supposed to figure out the value of the side with the question mark. So we're not doing angles this time. We want to know what that one is. Well, this is a real simple one because in parallelograms, and again, even though it doesn't say, I was not able to take a photo of the directions, but this is indeed a parallelogram. Okay, and because it is, there's something else that's true. Like in a rectangle or a square, opposite sides are the same measurement. So if this is 19, then the side opposite that, the question mark, must also be 19. So this is simply 19, and that's the end of it. This is a really short one. It's simply the same thing as what you see down there. Same. Which makes it real simple. Okay, opposite sides are the same. All right, let's move on. In this one here, we want to find the value of x. And once again, we are told, and I was able to get it this time, that this is, ta-da, a parallelogram. So we're going to use what we know about opposite sides that I just mentioned a moment ago. Opposite sides are always congruent. Okay, so because of that, I can write an equation based on this idea. So I could say that TQ, segment TQ, is congruent to segment SR. And because of that, x plus 2 is equal to 12, which means that x is equal to 10. The end. Believe it or not, it is really that straightforward and simple. Okay, opposite sides in a parallelogram are always congruent. All right, next one. This, once again, is a parallelogram. I apologize, I could not get the literature behind the question. And sorry, I'm trying to activate my screen sketch. There it is. But this is a parallelogram. Sorry about that. Parallelogram. So some things that are different about this one is that this parallelogram has a transversal that is running diagonally on the interior. And this is no different from anything else that we learned about with parallel lines. So I'm going to go back to that just so you have a default picture to look at. So two parallel lines and a transversal. And when you have an angle here and an angle right there, A and B are called alternate interior angles. And that means that those angles are congruent to each other when they're in those situations where they're on opposite sides. They're congruent. So I'm going to use that to my advantage because there's a little bit of strategy to this one. This is where I want to end up. I want to know what that is. And I have a number here and I have a number right there. Well, that's not a coincidence. And there's a reason why those are put in those locations. I'm going to use this 77 and what I know about transversals, which is, by the way, this whole segment right there, that's a transversal. I'm going to use what I know about that and say that this is also 77 degrees because these two, and I'm going to switch to a different color, this angle here and this angle right there, they are the same as these two over here. They are alternate interior angles. Okay, so segment GE is your transversal. That allows me to say that this is 77 degrees. And because I know that, now I can focus just on this upper triangle, which I have right over here. I can just focus on this one, that one. And if I were to erase the other triangle that I have, let's see if I can actually do that. I'll try to erase this triangle so that you cannot see it. So if I were to thicken the line, I'm going to cheat a little bit, okay? I'm going to cheat a little bit. We're going to erase this, then we're going to erase this over here. All right, let's just pretend that we can't see that. So if we focus on the purple one, then what we have is a situation where I now have to think of the angle sum theorem. So within any triangle, all angles add up to 180 degrees, all of them. So I can use that to my advantage, and I can build an equation. So my equation is going to be question mark plus 65 plus 77 equals 180. Since 65 and 177 together make 142, this is what I have, and the value of the question mark is now going to be 38 degrees. So this angle right here, angle E, right there, that's 38 degrees. Okay, and it does coincide with the way the picture looks. It looks like a really small angle, and 38 is a small angle measurement. So with that, we can finally move on. All right. Oh, actually, that brings me to the end of my video. I thought I had one more question, but I was wrong. So I hope that, that this video helped you better understand some of the basic principles of quadrilaterals and applying them in different scenarios. The nice thing is that a lot of this is based on prior knowledge about the angle sum theorem of any triangle making 180. Also, it goes back to parallel lines, transversals, and angles such as same side interior, alternate interior. And that's when you're dealing with quadrilaterals like this one that are called parallelograms. So please stop by, leave a comment. I appreciate any constructive criticism and ideas for how I can improve my videos. And as always, thank you for taking time to watch. Bye.